everyone. I am Nirisha, Assistant Professor in the Department of CSIT, working in MLR Institute of Technologies. Today we are going to learn about data types in the C language. So, coming to the data types. So, the data types will tell about what type of data we are using and how much memory it gets occupied to store that particular data. The data type will tell about some 2 points: what type of data we are storing and how much amount of memory it gets allocated to store that particular data. So the types of data types are primary data types, derived data types, and user defined data types. So the data types in the C program are used to specify what kind of value can be stored in a variable. For example, a is equals to 2 is an integer data type. B is equals to 2.2 is a float value. C is equals to C is a character value. So C language has some predefined set of data types to handle various kinds of data that we can use in our program. It has some predefined set of data types. So data type also specifies how much memory to be allocated and what type of values are to be stored in that particular variable. So for suppose if we have given a is equals to 2, a is equals to 2 is an integer value. The 2 will be assigned to the a variable. So to store that particular value, some memory will get allocated to store that particular value. So this is that point. It will tell about how much memory is to be allocated to store that particular value. In the C programming language, data types are classified as follows: primary data type, derived data types, and user-defined data types. So this is the primary data types. So the description of this: primitive data types. So we are also telling it as a basic data types that you are used to represent some simple values like integer, float, and characters. So the data type that we are using in our C program in the shortest form is int, char, float, and word. So these are the primitive data types that we are using in our C program. And coming to the derived data types, the data types that are derived from the primitive data types. Example like arrays, pointers, and strings. Array is a set of Array contains some set of elements that of similar data type. Like array can contain some set of elements of same data type. Similar data values can be contained in but multiple values we can contain in an array. Suppose, so 5 number of integer values we can store in an array. 5 number of character values we can store in an array. 10 number of float values we can store in an array. So these derived data types are derived from the primitive data types. And the next one is user-defined data types. User-defined data types are defined by the user himself. So the examples are structure, union, and enum. It was derived by the user. User-defined data types are derived by the user. So for suppose if you want to store a student record, a complete student record, is roll number, name, address, phone number, and also as marks. So this all contains some different data types. So that all different data types we can combine and store in a single data type, that is nothing but a structure and union. In both the data types we can store, that is structure and union. A complete student record we can store in the structures and union data type. So that data that can be defined by the user himself. So what kind of data he is required, so that only that particular information we can store by using this structure and union data types. So primitive data types. The primitive data types in C programming language are the basic data types. So primitive data types are also called as built-in data types, which are already defined in the system. So the following are the primary data types in the C program, like integer data type, floating point data type, character data type, and a void data type. So for integer data type, we are using int as a keyword, and for floating point data type, we are using float as a keyword, and for character, we are using char. Void is used for nothing, for empty. To store an empty value, null value, we are using an void. So this is used to store the whole numbers. Int is used to store the whole numbers. Float is used to store the decimal point values. Char is used to store the characters. So characters includes alphabets, digits, and special symbols. Characters includes alphabets, digits, and special symbol. And void data type, this is used to store empty. Null values can be stored in this void data type. So this is a simple chart that we are using, that we are representing the basic data types or primary data types or built-in data types or primitive data types. So the basic data types are integer, float point, and character, as we learned. And the next integer is again further divided into signed int, signed short int, and a signed long int. And the next one is unsigned int, unsigned short int, and unsigned long int. Signed is used to store both the positive and negative values, whereas unsigned is used to store only positive values. So signed is used to store the positive and negative values, unsigned is used to store only the positive values. So the difference between int, short int, and long int is it differs in ranges. The range will be differ from all these three data types. And the next float point is again further divided into float, double, and long double. These also differs in ranges. Character is again char, signed char, and unsigned char. So these are the primitive data types that we are using in our C program. The next one is integer data type. An integer data type is a set of whole numbers. Every integer value does not have the decimal values. So we are not using any kind of decimal values in this integer data type. We are using int keyword to represent that integer data type in C. The integer data type is used with different type modifiers like short, long, signed, and unsigned. So the type is integer, shortened, long-end, unsigned, and unsigned long-end. The size. This chart will tell about how many bytes of memory will get occupied to store that particular integer value and what is the range. Only this range of numbers can be stored in that particular data type, and this as the format specifiers. So what kind of format specifiers we are using so that the compiler can understand what kind of values we are reading and what kind of values we are printing. So the size of int is 2 bytes and the range is minus 32,768 to plus 32,767, and the control specifier or format string that we are using is %d. And the next for short int, the size is 2 bytes and the range is similar to the int. And the next, the format specifier that we are using is %d. For long int, the size is 4 bytes and the next, the range is this number, this positive number to the negative number to the positive number, and the %d is the control specifier that we are using to print the long int values. And unsigned int, the size is 2 bytes and unsigned long int, the size is 4 bytes. As we discussed regarding the signed and unsigned, signed means we can store only the positive values. So in the range you can find only the positive values, not the negative values. So here also it's an unsigned long int, so we can only find the positive values, and the format specifiers or control strings that we can use is %u for the unsigned int and unsigned long int data type. The next one is the float data type. A floating point data type are the set of numbers with the decimal point values, which has the decimal point values. For suppose if you are storing the data values which consist of point values, so at that time we are using the float data type. The float data type has two variants. One is float and other one is the double. This differ in the ranges. the two data types. These two data types refer in the ranges. We use the float data type to represent the floating point, and also double also is used to represent the floating point values. Double data type in the C language. So both float and double are similar, but they differ in the number of decimal places. The value contains 6 decimal places, whereas the double value contains 15 decimal places. So after point, we can if you are using float values, after point we can get 6 decimal places by using the float data type. And if you are using double, after point we'll get 15 decimal values if you are using double data type. And this is a chart that specifies the type, size, range, and also the what kind of specifiers that we are using. For float, the size in bytes is 4 data types, and the range is 1.2 e to the power of minus 38 to 3.4 e to the power of plus 38. And the format specifier that we are using is percentile F. And for double, the size is 8, and this is the range. And the format specifier that we are using is percentile LD. And for the long double, the size is 10, and this is the range to store the long double values. And the next, this is the format specifiers that we are using, percentile LD. Character data type. The character data type is a set of characters enclosed in a single quotes. So it is nothing but a set of characters. So what do we mean by a character? A character contains alphabets, letters, and also all other special symbols. So this character, the character can hold only a single character. This char data type can hold only a single character, and that single character also we are giving inside a single quotes. The following provides the complete details about the character data type. So the data type is char and unsigned char. The size in bytes are 1 byte for both signed and unsigned char. And the range is minus 128 to plus 127, and the range for this unsigned char is 0 to 255. As we discussed, if you are using unsigned char, so it contains only a positive values. And the format specifiers that we are using is percentile C for both unsigned char and char. And by default, if you are using int, it is treated as signed int. By default, if you are using char, it is treated as signed char. It means we can store both positive and negative values in this int, in both int and in signed int. In the char and in signed char also we can store both positive and negative values. So this is an example program to represent the data types. So all kind of data types we can use here. So here this is a header file, hash include stdio.h, and next one is the main function. The compiler starts reading from the main function. So mandatory section is the main section, and this is a int is the data type, float is the data type, and char is the data types. A, D, B, and CH are nothing but the variables. What kind of values we are dealing with? That values we are storing in this particular variables. And the values we are assigning by using this equals to operator, we are assigning the value to this variables. A is equals to 10, B is equals to 26.4, and CH is equals to A, and D is equals to 97. Here, by using this printf statement, we are printing the integer data type. See, and the control string that we are using is percentile D and percentile D. This is used for representing an integer value. And the next, A and D value. A will be reflected in the first control string place, and D will be reflected in the next control string place. So we should place in a sequence. And the next, by using the next printf statement, we are printing the float data type, and the format specifier that we are using is percentile F, and the value of B, whatever the value of B that we have, that will be reflected in this control string place. The next char data type, percentile C, is a format specifier, which is nothing but we are using those format specifiers to print what type of data we are printing. And whatever the CH value we have, that value will be displayed in the place of the percentile C. And if you run this particular program, The output is integer data type. See, by using printf statement, we are printing this integer data. Integer data type is 10, 9, 97. The A value is 10 and B value is 97. And in the next line, /n is used to come for the next line. If you don't use this /n, the floating point data type will be displayed over here. So /n is used to get for the next line. To use for the new line, we are using the /n. And floating data by next printf statement is float data point and data type. And the value of this B is 26.4 that we have already given. And we can see here all the 5 zeros, which means after point, the 6 decimal places that will be given by using this float data type. These are the 6 decimal places that after point that we got. And the next char data type is A. So whatever the ch value that we have, that value is A. So that A value will be printed over here. Coming to the summary, we have discussed about data types and also the types of data types. And data type will tell about some 2 points, that is what kind of data we are storing, and the next point is how much memory get allocated to store that particular data. And the types of data types are primitive data types, derived data types, and user-defined data types. As of now, we discussed only the primitive data types. All other data types we'll discuss in the further classes. Thank you. And in the next sections, we are going to discuss about operators and also the types of operators. Thank you.